Hello, welcome back. We'll carry on today on the overview of C programming. We start talking about arithmetic expressions, and then we wrap up today's presentation on formatting numbers in program output. Arithmetic expressions. To solve most programming problems, you will need to write some arithmetic expressions. In fact, a computer is called computer because it does basically computations. So arithmetic expressions are the core or the baseline of any computations that you are going to do. And these arithmetic operations could involve data of different types. They could involve numbers that are of single precision, double precision, numbers that are integers, small integer numbers, big integer numbers, very huge real numbers, very small, tiny real numbers. All these kind of types, they involve data types. So we are going to look at operations that involve two operands. So we are going to talk about arithmetic operations because they involve at least two operands. So for example, when you are performing, you are saying C equal A plus B, that means you have an arithmetic operator, the plus, and then you are performing two operands, A and B, and the result of this arithmetic operation is going to be assigned to a variable called C. So 5 plus 2, we have the addition operation where you are adding 5 with 2, the result will be 7 and will be stored somewhere. Same thing. We are multiplying some variable increment by 2. That result of this multiplication operation is going to be added to the variable sum. So as you can see, this is now one operand, which is itself an arithmetic operation, and this is the second operand, and the plus is the operator. Same thing, we have a different addition arithmetic operation which involves two operands, where each operand is itself an arithmetic operation. Here we have division, and here we have again the addition. So what are the operators that are used in C? We have arithmetic operators, we have the plus, it works with int and doubles. It means addition, so you could add integers or you could add real numbers. We have also subtractions, it works with minus symbol, it works with int and doubles, and basically are just doing difference of integer numbers or real numbers. We have the multiplication operator, which is symbolized by the star, and then it works on int and doubles. We have the division operator, which is the forward slash, and it works on numbers, and you have the remainder. Remainder is only valid for integer numbers. So for example, the remainder of 5 by 2, so basically what will remain when we do integer division of 5 by 2, so 5 by 2 will be 2, and then the remainder will be 1. Division. When you are applying to two positive integers, the division operator will compute the integral part of the result by dividing the first one with the second one. So you have to be very careful. When you have integer variables, make sure that you really want to do the division as integer operation. So for example, if you are dividing 7 by 2, where 7 and 2 are both real numbers or double or float, that means the result will be 3.5. However, when you make 7 out of 2, when 7 and 2 are both integers, this will be 3. Remember, the 0.5 has disappeared because we are talking about integer division. So we want to do the operands, they perform on the same type like the operator. Remainder. Remainder is the modulo, we call it also modulo, and which will return the remainder, integer remainder of the division. We're dividing the first operator by the first operand by the second operand. So 7 modulo 2 will be 1, and 6 modulo 3 will be 0, because 6 by 3 will be 2, and the remainder will be 0. So always make sure that you have this rule respected. So you don't want to get remainder of small number over big number. Data types. So for each variable specifying, we are doing declarations. How do we define the data types of an expression? So what is the type when we are doing some arithmetic addition between x and y? So if the operand 1 is x and the operand 2 is y and the operator is plus, what will be the type of this operation if both of them are integers? So that means defining or inferring the type of the arithmetic expression from the operands used in that operation. So if both they are int, of course the expression will be type. If either of them is double, of course the result will be double. Same thing, you could have operations with mixed type of operands. So in the mixed type operands, you have to make sure that the right thing is being done. For example, if you are doing an assignment where y is double, what will happen? It will be executed, and then of course evaluation will be done, and finally you get a double expression at the end. So you will get what? 5.0 out of 2.0, what the result will be at time. So if you want this assignment if you want this assignment to be integer when the result is integer, so what you are doing here, you are dividing a double with a double. So the result will be a double, but you are assigning that double to a smaller precision number, which is a y. So we are calling what? We are calling this by typecasting. So it will be the value of 2.5, and this 2 will never be stored, but you will lose some precision because you are assigning it to an integer value. However, if you really insist to have an integer division while your numbers or variables are double, you just do the casting with the specific type that you want to downcast to. So let's look at an example where we are computing an average. So we are reading numbers, we have some specific number of students. We are going to sum up all the scores achieved by the students, and then we need to compute the average. So basically, first of all, we ask what is the sum of the scores of the students. So we are assuming that this number is an integer. That's why we're using %d, and the value is declared as integer. And then we store it in a variable called total score. And then we ask for the number of students. So basically, the average will be total score over the number of students. However, because the average is a real number, and it could be a number with decimals, we have to make sure that we do some typecasting on total score and number of students, because they are both integers. So now when we print and we store the result, it will be a real number or double precision, and then we can safely print it using the float placeholder. So expression with multiple operators. Of course, all expressions could be split into two, because operators are either unary or binary. So a unary operator is an operator that takes only one operand. For example, a negative. When you want, for example, you have a number and you want to take a negative part of that number. So basically, you use a minus operator. In this case, it's not subtraction or difference operation, but you are talking about negation of the number. Binary operators. These operators, they take at least two operands. For example, the plus, the subtraction operator, not the negation, and the multiplication and the divide. A single expression could have multiple operators. For example, this is one expression which has mixed operators. It has the negation, it has the addition, it has multiplication, and it has the subtraction. And of course, in this case, when you have a mixed operation, we start talking about the order. So what is the order that the C compiler is going to use to evaluate this kind of expression? So we call them rules of evaluation. How do we evaluate these expressions? So we have parenthesis rule. So if you are in doubt, put simply parentheses in the part that you want to be computed first. Otherwise, the C compiler will follow its own operation. So we call it operator precedence rules. So we have multiple operators, so they'll be evaluated in the following order. So the first is the unary, and then the binary operators, which have the highest weight, the multiply, the divide, and the modulo. And then the third, the binary plus, and the subtraction. So associative rule. So unary operators have the same subtraction, are the same precedent, and are evaluated right to left. Binary, in the same expression, they are evaluated left to right. So keep in mind, unary operator evaluated right to left in the same sub-expression, binary operators evaluated left to right. So let's see this example. So we have a variable pi, which definitely is a constant because it's used by the define. As you can see, we are hinting by the capital letters used for defining the variables. We have a variable called double, and we have a variable called radius, and we have the same variable called radius. So basically, I'm squaring the radius multiplying by pi. So basically, I'm getting the area of circle. So how is it happening? So first of all, we take the first number, we do the multiplication. Remember, this is a binary operator, this is binary operator, and this is our now expression, or it could be a sub-expression in a very big expression. So now they'll be evaluated from left to right. So we multiply these two numbers together, we get the value. Then the result of this multiplication will be again multiplied with this variable, the same variable. And the result will be finally stored in the area. If we wanted to give some priority, we could have used parentheses. So by using parentheses here and here, so radius multiplied by radius will be performed first, and then of course we get the multiplication operator. So that's the idea. We get a pi, we get radius, we get multiplied by the same radius. So we get this left to right precedence. So the first multiplication operation will be performed. So we get these two numbers multiplied, and then the result of this will be now processed through the second multiplication operator. So we get this number multiplied, and we get the final result, which will be stored in area. Same thing. We have two sub-expressions in a big arithmetic assignment or expression. The first one is a binary operation, which is the subtraction, and it has two operands. And the second one is also a sub-expression with two subtraction operation with two operands. And both of them are used as sub-expression by using the parentheses. Now, as you can see, if we have not used the parentheses, what will happen? The division, the binary operation division, it has the highest priority in C program. But because there are parentheses, sub-expression will be evaluated first. So first of all, we'll get P2 minus P1, it will be operation. And then on the other side, T2 minus T1 will be performed. And the result of these two now will be divided. So if we have P1 equal to 4.5 and P2 assigned 9, T1 assigned 0, and T2 assigned 60, this is what will happen. We'll have P2 minus P1. This number will be subtracted from each other. So we get 4.5. And then on the other side, we get T2 minus T1. So 60 minus 0 to be 60. And then the first sub-expression result, 4.5, will be divided by the second sub-expression result, which is 60. So 4.5 divided by 60 give you 0.075. An interesting fact is here is that if we have performed the, without parentheses, if we have performed the priority rule and we get the precedence that the division operation will be done first, what will happen? It will happen that P1 will be divided by T2. So we get 4.5 divided by T1. If T1 was equal to, T2 was equal to 0, that means we'll have P1 divided by T2, which is 9 divided by 0. And then, because of the lack of parentheses, we get divided by 0, which is serious execution error. So let's look at another example. Here we have Z minus A plus B over 2. A plus B over 2 is a sub-expression plus W minus Y. The content of Z is 8, of A is 3, B is 9, W is 2, and Y is minus 5. Because we have sub-expression, we start with that first because it has the highest priority. In that sub-expression, we have addition and division, so division will have the highest priority, so we get B over 2. B is 9 over 2, because we have integer division, it will become 4. And then we have A plus 4, it will become 7. After that, we turn our attention to the right side because it has a unary operation. We start from the right. So the right means Y, which has minus 5, will become 5. So it became 5. So we have now 5. And then we are left with Z minus the result of expression, which is equal to 7 plus W multiplied by 5. Now we have subtraction, and we have addition, and we have multiplication. So we start doing what? We start with the multiplication. So 5 multiplied by 2 becomes 10, and then we have subtraction and we have division. Now they are equal priority, so we get Z minus the content, so 8 minus 7 becomes 1, and then from the other side we'll have 10, so 1 plus 10, it gives us 11. So now let's turn our attention to how to write mathematical function formulas in C. So we might have problems when writing formulas in C because they could be very confusing and given specific priorities for those operations. So in C we must always use multiplication. Remember, it has a star operator. So it's not by bridging two variables names together that you have multiplication, like in mathematical functions. To mean A times B, it has to be A star B. If you put AB, it's wrong statement in C. So if you have 2A, you cannot write 2A, you have to write 2 star A. So second, when dealing with division, also we have a problem of A plus B over C minus D. So you cannot write this way, we have to make sure that it will be A plus B, or in parentheses, will become a sub-expression to be evaluated to the side, over or divided by C plus D as a sub-expression. Because if we omit the parentheses, what will happen? The B over C will have the highest priority and will be performed first, which is not what is meant by this expression. So let's carry on with number formatting for real numbers. So when you are formatting the output for real numbers, you have to specify the number of digits required for the integer part and the number of digits required for decimal parts. So the same way like we did with integer parts, but now we have to include also the decimal part. As an example, we are trying to display a variable which has a number 3.114159. We are trying to print that with the placeholder f, and we are specifying that we need to print using 5 digits for the decimal part and 2 digits for the real part. So basically, you are going to have 5 spaces. So now The compiler will print a space because to hold 5 spaces, and then of course the dot and 2 integers for decimal part because we have specified 2 decimal part. The same number now when stored using 3 placeholders with 2 for the decimal part, it will be printed. Now it needs more space, so 3.14 because you are requesting 2 decimal parts to be printed, so 2 decimal parts will be printed and the remaining will be ignored. Same thing if you are printing on 5 digits and you are requiring 3 decimal parts, so it will be 3.1 and then 142 because now these are requiring 5 decimals. And the same example applies for the remaining.